Well, it's day 8. What's in there? Hi and welcome to another episode. What we've got here is the PiHut Advent Calendar Let It Glow, and we're on to day 8. So let's find out what's inside. Oh, looks interesting. It's inside the plastic bag. Oh, this is actually an anti-static bag this time around. Got some more cables, and we've got what appears to be an LED ring. There's 4 pins on it, so could it be it's addressable? As in the realms of the fact that we can tell it what colours we want, which ones to be. That'd be cool if we can. Let's go across the website and find out what we're supposed to be doing today. So we've got the wires and that there. We'll bring this back across again because we know we're going to need it. Don't forget to unplug it. So, Let It Glow Maker Advent Calendar Day 8 Rainbow Ring. It is addressable. And as always, let's get the mouse cursor across. Today we're playing with adjustable LEDs again, but this time it's in the format of RGB LED ring. It's another PiHut team favourite. Right, these rings are very popular LED format as you can make some really interesting patterns and effects with them and even build them into projects as a multicolour light source. Enough talk, let's get straight into the blinky. Warning! Some of today's activities contain fast flashing lights which may not be suitable for those with photosensitive epilepsy. Right, at least remember to tell people this time. Right, so contents. We've got what we've got. We guessed it right. So that's them there. Today's activities. We're going to learn more about the adjustable LEDs and how we can chain them together to make some really fun patterns. We already know how to set up use a single addressable LED from day 6, so we're expanding on that whilst reusing some of the functions and tricks we've learned so far. First, a quick intro into the LED ring in today's box. What is an RGB LED ring? These LED rings are simply 12 addressable LEDs in a row in a handy ring shape pattern circuit board, a PCB. Each LED is connected to the previous thanks to the in and out data pins these LEDs have. This means we can control all 12 of them individually using just a single GPIO pin from our Pico. You already know about the RGB and all that fun stuff from day number 6. This ring is standard RGB, not GRB. Yeah, that's nice. So let's jump straight into showing how you control your fancy LED ring. Construct the circuit. As always, make sure your Pico is disconnected from the USB. We've done that. Prepare the breadboard. Prepare the breadboard. Right, so it seems we're pulling everything out apart from the Pico and the wires we set up yesterday for the slider. So let's take the GRB LEDs out, just put them to the side for now, and all these wires. Careful, of course, because I don't want to ruin everything. There we go. Bunch of rat nest of wires now. As I said at the very first on day 1, I'm not using any sort of anti-static mat or anything like that because the average person hasn't got one. So, I'm not saying I'm not average, probably very much average, probably the embodiment of average. Probably when it says average, it says see Retro Box Room. But anyway, the thing is, we now have the board set up like this. So connecting the LED ring, it's a nice easy component to connect with the fixed legs and only 3 wires to hook up. First we need to fit the ring facing forwards, so this way. So all the white bits, they're the LEDs. That's the back side of it. Nothing of interest apart from some kind of serial number to let them know what component it is. I need to put the right pin of it into A1, and there we go. That's that. Obviously, when I'm showing you now, I'm going to have to tilt it up, aren't I, when we get some programs running on it. Right, so the first left pin, data in, we connect that to GPIO 2 or physical pin 4. Okay, so let's get a yellow wire. Let's just try to keep up with what they've got. Yellow wire, we need that on E4, and we need that to go to, where did it say? Physical pin 4. So that's A4 on the lower board. Then we've got a red wire. Yeah, red wire. We're going from A3 on there, and we want that to go all the way across to J1. Yeah. And the third wire, ground, use a grey wire for that one. Where we want to go with that? We want to go with that from the third pin from the left. So that's E2 across to, where do we want to go? Where did it say? Physical pin 3 of the board. So this is actually A3 of the lower board. There we go, we've got that plugged in. Take a look at the rear of the LED ring. It has pins connectivity labelled on the PCB. Not all components come with such luxuries. Now tells us to have a look at the back of it. Why not look at the back of it before? Right, let's zoom in. That would have been helpful to have a look at the back. Can we get some focus going on here? There we go. Oh, one way around. So D1, 5 volts, ground, and DO. Sorry, D1, isn't it? Yeah, D1. Oh, DI, no, silly me. DI, as in digital in, 5 volts, ground, and digital out. So we could even daisy chain these. So anyway, let's put that back, the right leg going into A1 and the LEDs pointing towards us. Let's zoom back out again. See, if it did say there's only 3 wires so far, so we don't think we need to do anything. So it's talking about everything, realms of there. So a quick first activity is to show you the minor differences you need to make in your LED ring code compared to the single RGB LED in day 6. It wasn't a single RGB, it was a GRB. Right. Right. We still import the nanopixel library and we set up the ring in the same way. However, the setup line now needs to be altered to reflect how many LEDs are in each chain. We know the ring equals we now use ring equals neopixel, brackets and everything else, pin 2 and 12, which is specifying the GPIO data in and that there's 12 LEDs in the ring. Simple. Okay, if you say so. Then to tell our code which LED in the ring we would like to light up, we can simply send ring 0 equals to 10, 0, 0. This is going to light up the first LED as the 0 is specifying the first LED. Remember, we count from 0 from the previous stuff that we learnt in the other days. And specifying the first LED in the index. Remember, indexing starts at 0. Oh, in fact, it's telling us that again. Right, note. Do you remember from day number 6 how the RGB value changed its intensity of the light? These LED rings can be very bright, so most examples we're going to stick to low intensity around 10 to save the strain on your eyes. Okay. Do you remember what it was that we're up to before? It was from 0 to 255. If you said that, very good. Right. Basically, let's get on with running the code, because it's going to do from 0 up to 11. Right. So, as always, I've clicked copy first, and first thing I should do is I get too giddy and I want to get on with doing it. I need to plug in the USB. So there we go, USB. It's plugged in on my computer, it's gone bidding. We press stop button. It's found it. We paste in that code, and as always, I think you should type it in. Press run, and there we go. If you can see there, oh, can you? Let's turn the lights down again. Down, 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 down. It's on a dimmer switch, you see, so it takes a little while to turn it down. You can just about see there, there's an LED glowing away in red. Definitely red. Let me see, glow against my fingers. Right. What can we do now? We could get on with the rest of it, really, couldn't we? So that's that. We'll press stop. If you need to turn it off, a minute. So what does it say here? So run the code example below. Try changing ring 0 number to a different value up to 11. Okay, so let's turn on number 7. Lucky number 7. Now, lucky number 7 would actually be number 8 in the LEDs. So we actually need number 6 if we're going to light up number 7. So number 6 is actually light number 7. And there we go, it bounced from the top. I'll just put it back to 0 again so you can see it go back down to the bottom. Ta-da! If you want to turn off the LED at any stage, just set the RGB colors to 0, 0, 0, but the entire ring will fill 0, 0, 0, like the example below. So you can put ring.fill and that'll do all of them. But we're going to ignore that at the moment because we just want to get on with doing stuff. But you play around with that. I recommend that you put it here before that ring.write, because that's what's actually writes it, sends a signal to the LEDs. Right. Where are we? By adding this to the start of the example program to clean up any LEDs, so the previous one. Okay, so it's going to teach us to do it that way. Fine, that's fine. So basically, like I've been saying from the get-go, you should initialize what's happening. This will do it. So we run that and it turned the LED off. You can see that from there. Right, activity number 2, lighting up multiple LEDs is super easy too. Just add another line for each LED you want to write. In this basic example below, we light up LEDs 1, 4, 7 and 10, and then making them blue, which in our index starting from 0 is 0, 3, 6 and 9. Okay, so we copy that, get rid of that last program, paste that in, run the program. As we can see, that's what it's doing, the different ones. I press play. And there we go, we've got, I don't know how to do it, show you, but you should be able to see that that one's glowing, that one, and that one. So, I've got the points of a compass now, all pointing blue. Or we can use a list. You know how lists work, we learnt them in day 4. We can create a list of specific LEDs in the index we want to light up and then refer to those list in our code. Basically, it's the whole list and loop stuff that we learnt the other day. So we go in, we delete, and we paste that in, and we run that code, and the same thing happens again, which is fine. But this time the code's a little bit, how can I say? We're cutting down the amount of code we actually have to type out, but still doing the exact same thing, which is fine. And we've got the fill bit in there so that we're initializing. So any mess we've left behind before, it will get it's resetting it back to being off, everything off, which is fine. A little delay for effects. Adding a simple short delay can transform your LED code from simple lighting up to a pattern. Take the code above, for example. If we just add one time.sleep one line to the end of the code inside our for loop, the LEDs will light one after each other. This is because the for loop will run for each item in the list. Without a delay, it's so fast you don't realize it's happening. That's why we've basically stuck a delay in. Okay, let's delete that. Get this new code. Run that one. Oh. Actually, I'll run that again because I didn't pick it up again. So turns it all off. Bottom one, left, top, right. There we go. Which in the realms of things, I suppose it's down, left, up, right. But either way, reminds me of that little Lego game thingy I've seen on the shelves in the shops. I forget what it's called, but it reminds me of that. I don't own it myself, but I think it's a game on a computer as well, actually. Spinning lights with while loops. What if we add the code above to the while true that runs forever, reduce the time delay slightly, and also clear the ring after each iteration in the for loop. That will give us an effect of the LED lighting one and the other, the constant cycle. Each LED in the list is lit for up to as long as we set the delay, then cleared, then the next LED in the list, the next LED in the list does the same over and over again. As the while true loop will start for the for loop. Here's the code for some added commentary. Give it a try. Right, so we've copied it. Make sure at the bottom of all data from the last one. Right, so let's have a look at comps. Define the strip pin number, that's fine. So that's the one. LEDs 0369. And then on the next one. And a bit of a delay. Okay. Let's hold it up and see what it does. Oh, there we go. Doop, 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 doop. We shall stop that. You've used the reverse method a couple of times now, but let's use it again with our ring, as it can help make some really cool effects. Okay, fair enough. Our light is going to bounce from one side to the other simply by adding a second for loop with the LED sequence reversed. The first loop will work through the list, lighting each LED in turn. Then once the loop is finished, it will move it to the next part of the code, which will the second loop, which is pretty much identical apart from that it was reverse function making LEDs run backwards. All of this in the true loop, keeping the bounce back and forth. Cool, give it a try. We've also changed the color. Okay, let's get rid of all this code then. Copy the code. Well, one thing I've not mentioned while doing all of this, basically you could put each bit of code in and you could save them. So you don't have to keep cutting and pasting when you come back from the first time, but obviously you can save and load, but I'm sure you know all of that already because, you know, using Word or Excel or whatever else, I'm sure we don't have to tell it, but just to point out it is there. Right, so we've got this one going. So what's it doing? It's going to be doing filling them all zeros and everything, basically turn them all off. Counting up. Let's change the colour. So we've got what we've got. Is that red or is that G? Is that going to be green? But anyway, I wonder what colour it's going to be. Sleep time isn't particularly a lot, and it's bouncing back. But it's going to do all of them this time. So I shall hold it up, even though that blue one's still going. We've got kind of a purple colour now. And it maybe looks blue on the screen, but it is quite a nice purple, like a violet colour, bright violet. Can you see? Maybe more on my hand. There we go. See, it's more of a purpley colour. That's cool. Let's stop that then. The spinning wheel of colour. This example uses the same concept as above, but we keep the LEDs lighting in a continuous cycle round and round again. Each time we get back to the first LED, we change the colour. We'll use a random method for the colours because we just think it's more fun than using a set list. We've also bumped up the max RGB intensity to 100 for this example, as it shows off the colours a bit better. Go to 255 if you want. Like I said before, that's how far it goes. The code inside the while loop first sets the random numbers integers for RGB colours with a max range of 100, then jumps to a for loop which then lights the LEDs in turn. Once the for loop is over, our while true loop starts and the process all over again. Okay, fine. That's understandable from all the different things we've been doing the past few days. Let's copy the code. Let's have a quick look. Yep, Linux, resetting the colours. RGB, we're taking the integer of it. So there's no, 0.5 or anything like that. From 0 to 100, so it's actually going from off up to 100 in brightness. RGB, going even quicker this time. And then we're filling it up. So let's get going with it, and I'll hold it up again. Oh, bright. Now sadly on camera you're not really getting to see. So I'll put my hand there just so that you can see the colour off of my hand, getting an idea of what colours are coming. So there's random colours. And it's going, zipping on round like there's, well, quite frankly, kind of like it's actually analog rather than digital. But it is all digital. Right, so stop that. Wherever it stops, nobody knows. Oh, full colour version. Rather than having a single LED spinning in a circle, you can fill the ring with each colour as it goes round. All you need to do is delete the last 3 lines of the previous example. Go ahead and try. Okay. Well, we're not supposed to have that 34. So these 3 lines here. Clear the ring at the end of each loop. But we're not going to do that this time. So we're deleting that. Going all the way back up there. That light will turn off because it's the first thing we do is reset them. So they're all staying on now, and it just keeps bouncing around. And this time I don't think you really need to put my hand in the way so you can get the idea of the colours, but because it's shocking the camera into going, oh, that's bright. Quite frankly, it's doing it to me now. I've got dots all over the place when I'm trying to look at these white bits of screen. So let's stop that. And what I'm actually going to do is delete all of this now because I want it to turn off. Whew, not so bright now. The double random ring. Another neat example that doesn't use a lot of code in this program is to select a random LED from our ring, display a random color on it, then select the next LED, and so on. If you run this fast enough, it looks really good. The best bit? It's using knowledge and functions you've already learnt. Great for practice. That's true. It's always nice to practice on what you do. Because was it 10,000 hours to become like fantastic at something? Anyway. Our while loop uses a random function to select the LED from our ring using the index of 0 to 11, then creates 3 random RGB colors variables between 0 and 50. All we need to do then is inject those variables into our usual code to drive the LED ring using ring random LED equals RGB. Give it a try. Okay. We'll delete that and then we'll press paste. And we'll hold it up to see what happens. Oh. That's what it's a bit like, isn't it? Does anyone... I know I've probably not done the tones correctly, but does anyone get what I was hinting at there? There's a few lens flares off of this, isn't there, as well, for my video camera? But you get the idea, it's random lighting, so that's obviously what you know what must use in their code to get that kind of flashing lights. Let's stop it again. And as I did last time, I'm going to go back up to here so that I can turn all the LEDs off. And that's day number 8. Lots of examples there, and there's a lot more for you can do with these LED rings depending on how far you want to take the code. Feel free to bump up the examples to a full 255 RGB brightness for some really impressive blinky. It was another good day for reusing things you've already learnt and using them in new fun ways. We'll be doing more with our RGB LEDs before the calendar is over. Note, we didn't remove the slider from yesterday's box as we thought it might be. You might like to try your hand at coding that for speed control, color selectors and other thing, and something else. All the knowledge and examples you can be found in the previous box article, or maybe, just maybe, we'll show you how in the future box. Okay. So to recap, bits and pieces, blah, blah, blah. Right, so if anyone does read the code, why don't you leave an example of your code in the comments and I'll cut and paste and stick them in the next video. If you are looking at this video by the end of, before I make the next one. So you've got roughly, I don't know, 20 hours time you've probably seen this to I'm starting to make the next one. So get that code in as fast as possible. While you're there, of course, and if you haven't already done so, please have a look in the description and click and have a look at the Discord and the Patreon links. Don't forget to hit that like button, that subscribe button, and definitely that notification bell. It all helps build up my little channel. But as always, happy gaming.